I am Anil Kumar, sharing with you a lesson with my bright student Akshit, whose average is more than 97% marks. Let us understand optimization questions based on exponential and logarithmic functions in this particular video. I hope it will help you for your test also. You can join my classes by sending an email on the address given. Let us now enjoy 1 hour session. Thank you. Hi Akshat, how are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So today, what do you want to do?
Sir, today I was hoping we can do optimization problems, but now with exponential functions.
Oh, you just started exponential functions. So what have you
Yeah.
learned in derivatives of exponential functions?
Yes, sir. So we've discovered the constant e and how it relates to the function e to the power of x. And then we found that the derivative of that would just be e to the power of x2.
Correct.
And then building upon that, we took b as any base to the power of x, and then found that the derivative of that would also be similar to e to the x, except we'd have to add a little bit more steps.
Correct. What are those little bit steps?
Yes, sir. So you'd have to take the natural log of the base and then multiply by the function itself.
Correct. Perfect. So that is perfectly fine. So what we
Yes.
will do is we will not straight go to the optimization, but we'll look into maximum minimum for some
Okay.
exponential functions, right? Which is kind of
Right.
optimization, right?
Yeah.
So we'll also take real life applications on exponential functions in the next class. Is it okay?
Okay. Yeah.
So in this class, since we just started, we will take some examples on just finding derivatives and maximum minimum
Yeah.
for those functions. Maybe we can get into curve sketching with exponential functions. Okay.
Okay.
So let me share with you whiteboard, and then I'll ask some questions. We can work on those types of questions. So
Yeah.
we'll work on a couple of questions. Let's begin with question number 1, which is for you. So f of x equals to 3 ln x over 5x. And we are given a closed interval, which is between 1 and e. Okay. So
Yeah.
that is the closed interval in which we have to work. We need to find the maximum and minimum value for this particular function. How will you do it?
Yes, sir. So first we would find the derivative of the function, right?
Yeah.
Yeah. And then we would get a critical number from there.
Correct.
And then you would plug that critical number in along with the intervals.
Correct. So find the derivative and then tell me what is going to be the answer and how are we going to do it?
Yes, sir.
So you want to use the quotient rule, right?
Yes, sir. We will use the quotient rule.
3 by 5 is a constant. It's a good idea to take 3 by 5 outside. Do you understand?
Okay. Yeah.
In that case, we don't really complicate it much. So it is only ln over x, which we are trying to find the derivative.
Yeah.
So before we find the derivative for this function, let us think about the function as 3 by 5 ln x over x. Is it okay?
Yes, sir.
We find derivative of the function of, we'll write 3 by 5, which is a constant, outside, and
Yeah.
derivative of ln x over x. Yeah. Now tell me what you get.
Yes, sir. So if you differentiate the top, right, it would be 1 over x. Yeah, 1 over x times x.
And then derivative of this times ln x, right?
Yes, sir.
So what are the critical numbers?
So, sir, it would if you equate it to 0, I think you should get. Sir, I'm actually a bit confused on the second part.
Means what?
So you know where we wrote 1 over x times x, right?
Yeah, yeah.
So that would be the derivative of the first part. And then, sir, where did we get the minus ln from?
Okay, so derivative of x times ln x.
Oh, okay, yeah.
So derivative of x is 1, so minus ln x.
Minus ln.
Yeah.
Okay, yeah.
So basically, this derivative can be written as equal to 3 over 5. And here we have 1 minus ln x. Sorry. So 1 minus ln x. I did not write it. 1 minus ln x, O x squared, correct? So what are the critical numbers?
Sir, it would be, yeah,
or does not exist. Both, right?
right.
Okay. But x equals to 0 is not in our domain. So if let's equate to 0. So we have ln x equals to 1, correct?
1, yeah.
That means x is equal to e, right?
Sir, sorry, one more question. So when we have ln x equals 1, right, it basically means e to the power of 1 equals x, right?
Yes, yes.
Okay, yeah. So then x would be equal to e.
X equals to e, right? So that becomes
Yeah.
a critical number. Now tell me, how will you ensure or figure out whether this is maximum or minimum? What will you do next?
You can find f of e, right, sir?
Okay. Yeah, so you find f of e, correct?
Yeah.
And you have 3
Or
ln
5e, right?
over 5e, right?
Yeah.
And you know f of 1. And you also
Yeah.
find f of e is also one of the critical numbers outside, right?
Right.
So it is in a closed interval, 1
Move.
to e. So basically these two values, right? So if I plug
Yes,
in
sir.
1, we get 3 ln 1 over 5, correct? So what are the two values?
So it would be 3 over 5e, right? For f of e.
ln e is 1, right? So 3 over
Right.
5e. And here we have ln 1 is?
Sir, I'll just pull up my calculator.
ln 1 will be what? So at 1 it is 0, right?
Oh, yeah. Okay, sorry. E to the power of 0 as well.
So the
Yes,
graph of
sir.
ln is kind of like this, right? So at 1 it is always 0, right?
Yeah.
So we get a minimum and a maximum, right?
Right.
Correct. So that is how we could actually work with logarithmic functions and natural logs, right? So that is
Yes,
why
sir.
I thought we'll just take simple equations to get used to ln and e, because many
Yes,
times
sir. Yeah.
I've seen that most of the students are not very familiar with using e and ln.
Yeah.
Because this is the first time we've been introduced to this.
Yeah,
right?
sir. That's why I'm a bit confused with it.
Yeah. Now it is clear, right?
Yes, sir. Now it is clear. Yeah.
Perfect. So that was our first example. Now let me take the second example now. Let me just clear this off. Let's take question number 2. Let's see. We'll take a couple of examples today. So I'll just copy examples from my previous videos so that you can later watch those videos also. So now we have another function which is let's say f of x equals to x plus 2 whole cube over
Yeah.
e to the power of x.
Okay.
And the function is between 0 to 2 in the closed interval 2. So whenever you have closed interval, we do have absolute maximum and absolute minimum.
Absolute minimum. Right.
So let's now figure out what is the absolute maximum minimum for this
Yeah.
particular function. So can you work it out now?
Yes, sir. So f prime of x would be 3 times x plus 2 squared times e of x, sorry, e to the power of x, minus x plus 2 cubed times e to the power of x over e to the power of 2x.
Correct. How will you simplify this?
So you can take x plus 2 squared and e to the power of x common.
Correct.
And then you would be left with 3 minus x plus 2 over e to the power of 2x.
Now what?
So, sir, now you can simplify the bracket to be minus x plus 1.
So minus x plus 1. Correct.
Over e to the power of 2x.
So this was square and this, so one gets e to the power of x, right? One of the
e to
x
the power of x. Yeah. And now you can find the critical points, right, sir?
Correct. So what are the critical points?
So it would be 1 and negative 2.
Correct. So critical number. Critical point. Now test. Critical points.
But minus 2 wouldn't be in our domain, right, sir?
Yeah. But we are looking only for this domain, correct? So
Correct.
within this domain of 0 to 2, we have only 2, which is 0 to 2 is of course there, and 1 we have, right? So
Right.
basically now we have to find the value of the function at 0, at 1, and at 2, right?
Correct.
Calculate, what do you get?
Yes, sir. So at 0, we should get 8 over 1, right? So 8.
8, yeah,
And then for 1, we should get 27 over e.
right? And for 2,
And for 2, we should get 64 over e squared.
yeah. Check decimal values.
Yes, sir. So f of 1 would be 9.9 approximately. And that one would be 8.66.
So that gives you maximum minimum value. You see that?
Yes, sir.
So that is how basically with exponential function you get the maximum minimum values, right?
Yeah.
What examples we took just now are working in closed interval, where
Yeah.
they are closed interval. So whenever you work in a closed interval, you do get absolute maximum minimum values, and
Yeah.
you do have a local minimum value, or when you sketch it, you'll figure it out what type of function this is, right?
Right.
So now let me also find some other questions from the playlist. We can discuss those now.
Okay, sir.
So let me now share with you my YouTube channel, and then we'll take up some questions from you. Okay?
Yes, sir.
This is one of the playlists which we have. Now, in this particular playlist, we have many videos which involve e to the power of something, right? And
Yeah.
natural law. So the very first video which you see is a multiple choice question. We have many videos on multiple choice, about 20
Yeah.
video. I'd like you to go through this video once you've understood the concepts and answer these questions, right? So this will help you to
Right.
understand the concepts fairly well, right? Now, here we do have like question number 8. Can you please read the question?
Yes, sir. Determine the absolute extrema of the function y equals x minus 3 times e to the power of x on the interval -1 less than or equal to x, which is less than or equal to 3.
Okay. So basically, you'll do exactly what we did in the previous two examples.
Right.
So
Yeah.
we have a defined closed interval in which the function is continuous. And we'll find the critical number, check the value of the function at the critical numbers and at the boundaries. Whichever is maximum will be absolute maximum, whichever is minimum becomes the absolute minimum. So those are straight questions. Now let's look into some application questions, kind of word problems, right? So there are about 8 videos which have been picked up from previous tests. Now here is another very interesting question, set of videos, set of questions for you. Can you please read the question?
Yes, sir. Question 1. Find the maximum and minimum value of the function y equals 2x cubed minus natural log x squared over the interval 0.1 to 2.
So this could be additional question for your practice, correct? So we're done with that first type of questions, which are straight, in which we are given the boundaries and we need to find maximum or minimum. Perfect. Can you please read question number 2 now?
Yes, sir. The concentration of a certain prescription drug in bloodstream after a single dose can be modeled by the equation C equals 100t e to the power of minus 0.5t, where C represents the concentration of the drug and T represents the time in hours since the drug is taken. Determine the maximum concentration of the drug in the bloodstream and when it occurred.
When it occurred. So tell me, how will you do this question and what type of graph do you expect for this particular function?
Yes, sir. So when we take medication, right, so the concentration is usually supposed to decrease as time passes by, right? So I think it should be somewhat of a decay graph.
It is kind of decay, but let's see, 100t e to the power of minus 0.5. So as soon as you take medicine, so medicine takes time to get into your stream, correct?
Right.
So it increases, and then it decreases, and then it decreases over a period of time. Its effect decreases, right? So very important function from this point of view, and definitely our approach is going to be to find the derivative of this particular function, analyze the derivative,
Yeah.
And we could actually extend this question in curve sketching. Very important question from curve sketching point of view also, right?
Yeah.
And sometimes when we say, well, this is kind of a antibiotic, and at what level we may define a level at which the second dose has to be taken, right?
Right.
So those type of questions also can have a similar, approach.
Yeah.
Perfect. So, so that is the type of question which is pretty good from examination point of view. Can you please read question number 3?
Yes, sir. In a telegraph cable, the speed of signal is v of x equals x squared, natural log of 1 over x, where x is the ratio of the radius r of the cable core to the overall radius large R. Find the value of x that maximizes the speed of the signal if r over 10 is less than or equal to small r, which is less than or equal to 9r over 10.
Correct. So that is another type of question. And as you can see, in many real life situations, we have exponential functions as examples, and we would
Yeah,
like to optimize the real life situations where that type of questions will be asked. Correct?
correct.
So can you tell me how will you do question number 2?
Question number 2, sir, or 3?
Well, let's start with 2, then we'll go to 3.
Okay, yeah. So first we would have to find the derivative, right?
Product rule, correct?
Yeah, product rule.
And then find the critical numbers, right?
Yeah,
So
and then
without getting
critical numbers.
let me also share with you the solution, and
Yeah.
we can just see the solution and discuss. Okay. So that was
Okay.
the first question, which was straightforward. Derivative of ln x, and then you could do it. Solution is being shown here. Now here is your question number 2. Okay.
Yeah.
So Akshit, as you were saying, we have the function concentration of any drug in the blood is given by a formula, and then derivative. So derivative, applied the product rule and take e to the power of minus half t common, and within the
Yeah.
brackets you get another function in time. Exponential
Right.
functions are never zero, right?
Right.
So
Never.
that outside thing will not be zero. Only
Yeah.
at t equals 1 minus half t could be equal to 0, which
Yeah.
happens at t equals to 2, right?
2.
So
Yeah.
now you get the value of t, which is a critical number as 2, and you can analyze the situation from the given boundary conditions and the value of 2, right? This says
Right.
where C represents concentration of this, determine the maximum concentration of the drug in the bloodstream when it occurs. Now, at this time, to find the maximum, you can also do the second derivative. Do you know how second derivative will help you to understand that this is a maximum? At t
Yes,
equals,
sir.
yes, tell me.
So, sir, when we equate the f prime of x initially to 0, right, and that critical number, if the second derivative is a negative number, then we know that it's a maximum, and then positive would be minimum.
Perfect. So in exponential function, second derivative may be a better test to do because
Yeah.
the derivative of exponential function is very simple. It is same as
Simple.
the
Right.
function itself. So
Yeah.
second derivative test normally helps, and in this particular case, you have the function right there. If you do the second derivative, you realize that plugging in 2 will give it a negative value, and therefore
Yeah.
the critical number represents a maximum. Right? You get the idea. So
Right.
that may
Yeah.
be a good way to prove it. You could definitely analyze the first derivative to write down the
Yeah.
answer. How? Second derivative test is always a very good test for exponential and logarithmic functions. Okay?
Yes, sir.
So anyway, in this particular case, we analyzed the very first derivative, mainly because
Yeah.
many students do not apply the second derivative, right? And they are
Right.
still working with the first derivative. As you can see, if you test it, then the function increases up to 2 and then decreases. And so
And then decreases.
we
Yeah.
have the maximum at 2. Perfect.
Yeah.
Now, let's look into the solution of question number 3.
Yeah.
Okay. So now, can you explain the solution?
Yes, sir. So as we were given the function, we found the derivative of it, and then I think we took x common from the first step of the first derivative, and then we got that 2 natural log of 1 over x minus 1 in the bracket, right? So then we know that x would be 1 over square root of e, and that would be our critical number, right?
Correct.
So then after that, we can plug that into our function and then see what value it would give up, right?
Yes. Because the boundary conditions are given to us in this particular case. And therefore, we can plug in the values and get our answer. Correct?
Yes, sir.
So that is how you're going to do it. Now, as you can see in this playlist, there are many videos. You can actually look into many of these, some of these examples and perform uh, some practice, right? Here is
Yeah.
a very interesting video which I'm going to share with you.
Yes, sir.
E to the power of x, you just watch this. And it's kind of a very difficult question. It's not that simple.
Yeah.
Now, can you find the derivative of this particular function? Try.
Yes, sir. I'll try.
Yeah.
Sir?
Yes.
You know how it's x to the power of x, right?
Yeah, x over x.
So yeah. So can I rewrite it as just x to the power of x and then whole bracket x? Or that would be incorrect.
You could do that. But see, whatever, if you do the direct method, it's going to be very tricky and difficult. Okay?
Yeah.
So, what we have done here is, I think, I'm not seeing the solution yet, but a good way of doing it is take natural log on both sides or log on both sides.
Oh, okay.
Derivative of log is also very simple.
Yeah, it is. Yeah.
Derivative is 1 over x, correct?
Correct.
And then you get into the terms with e, so it becomes simpler. If you
Yeah.
work with this function directly, the solution is going to be very difficult, right? So therefore,
Right.
I will now share with you the solution of such question, which is brilliant. Okay,
Yes, sir.
what we are trying to do here. So I'm just going to mid of the video just to show you the strategy which we are going to adopt to find the derivative of this particular function. Do you see what we have done?
Yes, sir. Taking log on both sides.
Yeah. So we took log on both sides. Natural log we took, right? So ln
Yeah.
1 is equals to ln of x to the power of x to the power of x, correct?
Correct.
Now we have applied the power rule. X to the power of x times ln x. Do you see this?
ln x. Okay. Yeah.
And now if I do the derivative, I can use the product rule, correct?
Right. Right.
ln y derivative is 1 over y dy dx, correct?
Correct.
So you have dy dx on the left hand side, and on the right hand side, I can use the product rule, correct?
Correct.
So that makes these things very simple. You get
Yes,
the
sir.
how we have done it.
Yeah, it simplifies everything.
It simplifies really, and those are very simple derivatives. So once
Yeah.
you continue with this, I mean, you will get a critical number. I mean,
Yeah.
you can find the derivative. It's just a product rule on the right hand side, right? So
Yeah.
at the end, it might be slightly tricky to put the things back into x to the power of x to the power of x form and write
Yeah.
down the answer. But I think I have given you a good idea of how do we use natural log to
Yeah.
find the derivative of exponential functions.
Right.
So I'd like you to copy this question, try it on yourself, and solve.
Yes, sir.
Right? That'll be good.
Yeah.
It's just a 5-6 minute video, but it gives you a lot of concepts.
Right.
So let's get back to our very first question, which was a multiple choice question. It is a very interesting video, where I have taken many questions. So
Yeah.
let's try to answer these questions one by one. Question one for you. Can you please read and answer the question?
Yes, sir. Slope of the tangent line at x equals 0 for the function e to the x is 1.
Correct. E to the power of 0, which is 1. Correct. Okay. Let's see. Question number 3. The derivative of this function is what? Tell me.
Right. So you can rewrite this as e to the power of x plus 2 to the whole power of 1 over 2, right?
Yes.
And then you can use product of a function rule.
Yes.
So I think it would be 1 over 2, and then e to the x plus 2 to the power of minus 1 over 2 times e to the power of x.
So which
Right,
option?
sir? So I think it would be, so it would be B.
Correct. B.
Yeah.
Good. Okay, this question.
Yeah.
Can you read and answer?
At what value of x does the function f of x equals x squared plus 1 e to the power of negative x have a critical point?
Correct. Tell me.
Right, so you'd have to find the derivative, right?
Yes.
So using the product rule, it'd be 2x times e to the negative x plus x squared plus 1 times negative e to the power of negative x.
Correct.
So you can take e to the negative x common, right? So
Yes. Yes.
negative x and then 2x plus squared plus 1 times minus 1. So it would be 1.
Correct. What?
Yeah.
Because x minus 1 whole square is what you are going to get, correct?
Right. Correct.
Perfect. Perfect. Good job. Here's your next question.
Yeah.
Okay, anyway, look at the question. The derivative of y equals to ln e to the power of x square root x is what? The solution is right there. But
Yeah.
if you have to do it, what will you do?
Right. So, sir, I think I would split up e to the x and then root of x, right? So take natural log of both, because using the log rules, it would be ln ex plus ln root of x. And then find derivative of both using the addition rule.
Correct. You could do that. You could also go direct, right?
Yeah, you could.
Ln of this, then the whole thing comes down and the derivative using product rule in the new.
Yeah.
You could do either way.
Right.
Question number 7. Can you tell me how you do?
Yes, sir. Determine concavity of the graph of y equals x e to the 4x plus 1 and x equals minus 1. Okay, so if you plug in x equals minus 1, right? So you would get a function of okay, sorry. First you'd have to find the derivative, right? So the first derivative.
Yeah.
And then using that, you can find the second derivative again, right?
Correct, correct.
And then plug in minus 1 and see the sign.
Concavity changes or not, right? Okay.
Yeah.
And see the sign. Correct, correct. So basically, for concavity, does first derivative play any role?
No, sir.
No. Only second derivative plays a role. Of course, you
Yeah.
have to find the first derivative to get to the second derivative. That's a different story.
Correct.
But analysis of first derivative does not play any role in finding concavity of a function. So find the second derivative, plug in, and find the answer, right?
Yeah.
Question number 8.
Yes, sir. Determine the absolute extrema of the function y equals x minus 3 times e to the x on the interval minus 1 less than or equal to x less than or equal to 3.
You find the derivative and plug in and check the value, correct?
Yeah.
Okay. So later you can go through this video, and here we have a word problem. Can you please read the question?
Yes, sir. The decay of a certain substance is modeled by the function n of t equals 100 times 3 plus e to the power of minus t over 3, where the number of particles is represented by n in a time of t hours. How fast is the number of particles changing when t equals 3 hours? Okay, so you find n prime of t, right, sir? And then you plug in n prime of t.
Correct.
Yeah.
So relatively simple questions to begin with, but it gives you good practice on derivative of the function. And also we have rate of change, maximum, and optimization questions all included in this particular set of let's say 10 odd questions, correct?
Yeah.
So really definitely helps you, right?
Yes, sir.
Determine the equation of tangent to the curve defined by this at a point where x equals to 0. Well, find the derivative, find the equation of the tangent. Perfect.
Right.
That's how you should be doing these.
Yes, sir.
Now let's look into derivatives of logarithmic functions. We have mainly seen derivatives of exponential functions so far.
Yeah.
So first is, to begin with, you should have set of formulae with you. All the derivatives of exponential and logarithm, there are just 4 or 5 formulae, which you should have handy, right? So can you tell me, what is the derivative of a to the power of x?
Yes, sir. It would be e to the power of x times natural log of a.
Correct. So basically, what we really do is we can write this as an exponential function, right? You see y equals to a to the power of x, right?
Yeah.
If I take natural log on both sides, ln y, see how do we derive the formula?
Yeah.
Now take ln y both sides, so ln a to the power of x, which is x times ln a, right?
ln a. Yeah.
Now you take derivative, differentiate with respect to x on both the sides, you get 1 over y, dy dx
Okay.
equals to ln a, right? And dy
Yeah.
dx is 1 by y ln a, right?
Right.
So you have your formula, which a to the power of x times ln a.
ln a. Yeah.
Similarly, we can derive the formula for log to the base bx, because that
Okay.
base can be changed to ln x, right?
Right. Yeah.
So once you change the base log to the base bx to ln x, you get ln x over ln b. So you get ln b in the denominator. You get the idea.
Oh, okay. Yes, sir.
And
Yeah.
that is why this is your formula. So first thing is, I would like you to copy these formulas from this particular page,
Yes, sir.
clearly understanding how we derive them. Only then
Yeah.
you will remember them for a longer period of time.
Yes, sir.
Otherwise, you can just remember but not retain that for a long period of time.
Right.
That's it. So we have these three very important formulas listed just before you. And
Yeah.
we know the derivative of ln x is 1 over x. From that derivative itself, we are finding other derivatives, basically.
Right.
And that's simple. A to the power of x, take ln x both the sides. This strategy helps you to solve many derivative questions which are related to natural log,
Yeah.
or exponential functions. Same strategy we are adopting.
Yeah.
Now, let's move forward and take some examples. Now, there are many examples in this case. Can you figure out? Equation of tangent line to y equals to log to the base 2x at 8, 3 is what? What will you do?
So, sir, we can find the derivative first, right? Y prime.
Right?
So it would be ln x over ln b again, right?
Mm-hmm.
Using the formula. And then once we get that, we can plug in the x coordinate as 8 and find the slope of the tangent. And then based on that, we can plug it into y equals mx plus b form or slope point form, right?
Right.
And then solve for b.
Right. Very important question.
Yeah.
I'd like you to also go through the second video in this particular playlist. First video is more on exponential functions. Second
Yeah.
one is on logarithmic functions. When you master these two videos, then you should go through the other videos on this playlist to get into further details and understanding better of this particular topic. Is that
Yeah.
clear?
Yes, sir.
Okay. So there are many questions based on this, as you can see. This is interesting. Differentiate this and find the domain of its derivative. Domain of its derivative, not the function, right?
Okay. Yeah.
So find the derivative and then the domain.
So how would we find the domain of the derivative?
Oh, we have this domain expression, right? Derivative, right? Which
Yeah.
is 1 over 2x plus b comes in the denominator.
Oh, okay. Okay. Yeah. Yeah.
And then we have the derivative. Simplify, and then you can see that the denominator has to be positive, right?
Right. Yeah.
I mean, the cannot be 0, but the function has
Cannot
to
be
be
0.
positive, right?
Yeah.
So from there you get the domain.
Right.
We have to exclude the point where, let's say, x equals to minus b by 2 will be excluded. That is 0, right?
So, sir, it would be like almost like a vertical asymptote, right?
Yeah, at that point, yes.
Right. Okay.
So that is how you find the domain. Let's continue from here. So you have this inequality going on the top, right? 2x
Yeah.
plus b has to be greater than 0 because
Right.
a is positive and 2 is positive. We are assuming a and b are positive in this particular case, right? So solve
Right.
this inequality, 2x plus b equals to 0, and get your answer.
Okay. Yeah.
Basically, that is the concept.
Yes, sir.
Clear?
Yeah. Clear.
That's how you do it.
Yeah.
Interesting question.
Yeah.
Next question. Differentiate 3 to the power of y equals to x square plus 1. Actually, it is a very difficult question straight away. But if you take
Yeah.
natural log from both the sides, see
Both
how
sides. Yeah.
simple it becomes. You see that?
Yeah.
Otherwise, it was a very difficult question.
Yeah, for sure.
So as soon as you take natural log, it becomes y ln 3. Y ln 3.
Yeah.
Now
Y ln 3.
and the other derivative is simple, right? 1
Yeah.
over x square plus 1 multiplied by 2x. You are done.
Right.
So taking natural log on both the sides helps you to find derivative of the functions very easily. That is the whole concept. So we are
Yes,
using
sir.
logarithms to find derivatives of the functions.
Yeah.
So we got good number of, see question number 10. Maximum minimum for x square ln x. So earlier you worked more with exponentials, now you work more with ln and
Yeah.
natural log and logarithmic functions. Do all those things which you did with other functions so far, and then you could also master these.
Yeah.
So try to sketch this function later. We are only
Yes,
doing
sir.
part of it in this particular
Right.
video, but you should extend it to sketching the graph of x square ln x. You get the
Yeah.
idea. So like can explore more. Now
Yeah.
on exponential functions playlist, we could have optimization questions also.
Okay. Yeah. So, sir, it would be like these equations in word problems, right? For optimization.
Yes. Now, many examples you saw, like natural cooling and effect
Yeah.
of medicine and all those things, correct?
Right.
So, many optimization questions will involve all those things. So,
Right.
now here, for example, marginal cost. You did financial related questions earlier, correct?
Yes, sir. We did.
So, here is a very good question based on marginal cost, which is a rate of change. So, have a look at this.
Yes, sir. Okay. So they've given us that C bar is the average cost producing Q units of a product, right? So we have to find the marginal cost. So it'd be the derivative, right, sir? Of the given function. Yeah.
So
And
those are good examples. So you can search for many examples like this and try
okay.
them. Right. I'll also share with you some more questions later.
Okay.
You can also watch my videos with Amy.
Yeah.
This is around 50 minutes video, one full class,
Yeah.
in which we have many questions. Now, different types of questions are there in this. So that will
Yeah.
help you to understand many more concepts, not just logarithmic functions, right? For example, this,
Right.
I mean, let me enlarge the screen. It's a practical example, as you can see.
Yeah. Okay. So this is similar to like a decay type question, right, sir?
Correct.
Yeah.
So these type of questions you could definitely work on to master
Yeah.
the, you know, your skills on this exponential functions. Perfect.
Right.
So I
Yes,
think
sir.
we can end the class here, but I'd like you to summarize your learnings today from what you learned about exponential and logarithmic functions. Tell me.
Yes, sir, for sure. So when we started the unit, right, sir, I was still a bit shaky on my logarithmic rules. So I think this lesson has solidified my learning. And with the introduction to like E and everything, it was a bit scary at first, right? But the way we went through the multiple choice questions and the way we did those problems, I think I'm confident now, and I just need a bit more practice.
Correct. And
Yeah.
that's a wonderful playlist. Just practice with that playlist. Very simple questions we are beginning with, right? 10 of
Right.
and 10 of natural log. Once you
Yeah.
do those, then you know how to work with what is LNX, right? You will understand.
Right.
And then
Right.
you take up other challenging questions, maybe maximizing
Yeah.
effect of the graph or optimization questions or decay questions, anything, right? Because there are
Right.
hundreds of applications where E is
Yeah.
used in the functions. Is that okay?
Yes.
Great. So we'll end the class here. Practice from my playlist. That'd be great.
Okay, sir.
Okay then. Thank you.
Okay, sir.